Hello GCC, this is the Chapter 9 video number 3. So this is third in the series of Chapter 9. So this is more just for fun now. Enamel erosion occurs below a pH of 5. So look at all of these sodas and the pH values. So again, pH goes from 0 to 14, 7 is neutral. As we go below 7, it's acidic. So 5 and below can start to erode your tooth enamel. So look at all of these diet and regular sodas. They're all below 5. So they all cause acid erosion. Here's some pictures of lovely teeth that have had acid erosion. So again, your dentist can tell if you have acid erosion, and there's really 3 main causes for acid erosion. One is drinking a lot of acidic beverages, a lot of soda, a lot of juice, without rinsing with water afterwards. Second would be someone who's bulimic, because they're throwing up and the acid from their stomach is coming into their mouth and eroding the enamel off their teeth. And then 3 would be people that use meth. So meth mouth and bulimic mouth and acidic beverage mouth all kind of looks the same. So your dentist can tell if you're doing one of these 3. So do be careful what you're drinking. Alright, now we're going to talk about solubility. Solubility is basically the amount of solute that can dissolve in a given amount of solvent. So again, solvent is typically a liquid like water, and then solute is what we put in the water to dissolve in it. Kind of like instant coffee, that's a solution. How much instant coffee can you put into hot water and make it dissolve? You know, eventually reach a point where it won't dissolve anymore. So we're going to look at solubility rules. Solubility rules are going to be in the bottom corner of your periodic table. So the solubility rules on our table are for ionic solids placed in water at 25 degrees Celsius. So if it says soluble, that means the ionic compound that you've looked up dissolves pretty much completely, 95% or more. It's going to break apart into ions, just like the strong acid broke apart into ions. So it gets in parentheses an AQ, it's soluble. Insoluble means the ionic compound only dissolves a little bitty bit. So it's kind of like the weak acid and the weak base that we saw. Most of it's going to stay together. Only a very small amount, maybe 1 to 5%, maybe even less, is actually going to break apart into ions. Most of it stays together. We call that insoluble. When most of it stays together, most of the cases it's a solid and it just sinks to the bottom. So we're going to give it parentheses S. So here's the solubility rules. I want to point out how to use these rules. Is you start in the first column, number 1, lithium, sodium, potassium, ammonium, always soluble. If your compound contains one of those ions, you stop. It's rule number 1, it is soluble. We always start with rule number 1. Then we go in order through the first column, through the first 5. And then, only then do you go to the second column and go through those 1 through 5, or on your periodic table, it actually says 6 through 10. So, if you're looking up a compound, whatever ion you get to first will govern that solubility rule. For example, if we said sodium chromate, you do not go to rule number 1 and say sodium is always soluble, but then over here it says chromate is insoluble. Okay, no, you went to rule number 1 first, found it, that's the rule. Don't keep looking for the rest of your compound. Sodium chromate is soluble because rule number 1 comes first and it trumps all other rules. You do not go look at the chromate rule that says insoluble because you already had sodium in rule number 1. Always start at rule number 1 and go from there. They're in order of importance. Okay, let's have another example. How about magnesium iodide? Magnesium iodide, Mgi2. So we're looking for Mg or I, whichever we come to first. Okay, rule number 1, there's no Mg or I. Rule number 2 is not Mg or I. Rule number 3 is not Mg or I. Rule number 4, ding ding ding, it has an I. So notice it also has a but. But means except. So Cl, Br, and I are soluble unless they're bonded to silver, mercury, or lead. Okay, I said magnesium iodide, not silver, mercury, or lead, so it is soluble. It's soluble. Okay, so the first rule we came to is the I rule. We don't continue looking for an MG rule. It's the rule you come to first. That governs the solubility. Okay, let's try another one. Let's try silver sulfate. Silver sulfate. So we're looking for silver or sulfate, whichever rule we come to first. Rule number 1 is not about silver or sulfate, nor is 2 or 3 or 4, 5. Rule number 5 is sulfate. Okay, rule number 5 is sulfate. They're soluble, oh, but there's a but. So except calcium, strontium, barium, silver, and lead. Ah, there's silver. It's in the exceptions, so it is insoluble because it's in the exceptions for rule number 5, sulfate ions. It is insoluble. All right, now I want you to determine if the following are soluble or insoluble in water and write the correct physical state next to each. Again, you get an AQ if you're soluble, you get an S if you're insoluble. Go ahead and look at those 5 examples. Na2S, AlOH3, AgBr, CaCO3, KNO3, and pause the video now. All right, welcome back. Let's see how you did. Sodium sulfate is soluble. It gets an AQ. Rule number 1, sodium. We don't have to look for the sulfur rule. We came to rule number 1 first. Aluminum hydroxide is insoluble, so it gets a solid. Insoluble, the very last rule. If you're looking at your periodic table, it's rule number 10. Rule number 10. Hydroxides are insoluble, and aluminum is not one of the exceptions. So solid. All right, what about AgBr? AgBr, insoluble. Rule number 4, insoluble, because Ag and with Br is one of the exceptions. It is insoluble. Rule number 4 is the Br rule, but silver is an exception. What about CaCO3? Also insoluble. It's the first rule in the second column, the insoluble column. Rule number 6 over here in the insoluble column. First rule, carbonates are insoluble. Last one, potassium nitrate. Boom, potassium, rule number 1, soluble. All right, I hope you did well with your solubility rules. Remember, it's always the first rule you come to first. You have soluble in the first 5 rules, and then insoluble in the next 5 rules. And you always start with rule number 1, and you go until you find part of your chemical, and then that is the rule. Go with that rule. Good luck. All right, now we're going to talk about electrolytes. Strong electrolytes are good conductors of electricity. The chemical completely ionizes in water, meaning all ions. What did we just talk about that's all ions? Strong acids and strong bases. You're correct. What else is all ions? Breaks apart completely. Anything in the soluble side. So soluble ionic compounds, strong acids and strong bases, or strong electrolytes. Some examples: potassium bromide, nitric acid, potassium hydroxide, sodium chloride. They're all soluble ionic compounds or strong acids or bases. So completely soluble, all ions, strong electrolytes, good conductor of electricity with all those ions in the solution. Let's go to the other extreme. Non-electrolyte. Doesn't conduct electricity at all. There's no ions, so it can't be ionic. Okay, if it's a non-electrolyte, it's not ionic. Meaning, what's not ionic? Well, covalent. So this is our covalent compounds, because they have no ions at all. No ions. Non-electrolyte. Don't conduct. Examples would be pure water, carbon monoxide, and then various sugars like C6H12O6. That's a covalent compound because it only contains carbon, hydrogen, and oxygen. So non-electrolytes. And then we have the ones in between, the ones that break apart a little bit, 1 to 5%. Break apart a little bit. They do break apart just a little bit. So those are weak electrolytes. They're not very good conductors, but they do conduct a little bit, but they're poor conductors. The chemical partly ionizes in water. There are a few ions. What have we talked about that ionizes a little bit? Yeah, weak acids and weak bases. Very good. What else ionizes a little bit? The insoluble ionic compounds. Again, they ionize a little bit. Even though they're insoluble, they ionize a little bit. So our insoluble ionic compounds, weak acids, and weak bases, or weak electrolytes. Let's look at some examples. Hydrofluoric acid, magnesium hydroxide, silver chloride, and carbonic acid are all examples of weak electrolytes. So an electrolyte means there's net movement of ions. It will conduct electricity. It would light up a light bulb if it was connected with 2 electrodes stuck in the solution, because we do have ions will conduct a current. So it can light up a light bulb. Negative electrodes and positive electrodes sticking in a solution. Nothing's going to happen if it's a non-electrolyte, because there's no ions present. Electricity is not conducted at all. Okay, no electricity conducted in a non-electrolyte. So here we got 3 pictures. Which one is the strong electrolyte, which one is the weak electrolyte, and which one is the non-electrolyte? Go ahead, pause the video and have a good look at these. Okay, so which one is our strong electrolyte? You're correct if you said the one with KCl. Why is that one strong? Because it's all broken apart, it's all ions. All ions is strong. Strong, all ions. Okay, which one is weak? In the middle. You're correct if you said the one with few ions, the magnesium hydroxide, the Mg+2 and 2 OHs, but most of it stayed in the bottom of the solution as a solid. Okay, that's one of our insoluble ionic compounds. It's also a weak base. It is a weak electrolyte. So which is our non-electrolyte? Well, the only one left is CH4. If we somehow dissolved CH4 in water, it wouldn't break apart at all, because it's not made up of ions. So it's a non-electrolyte. We're going to classify all of these as strong, weak, or non-electrolytes. I'm going to need you to pause the video, write these down. Remember, look at your solubility rules. Soluble gets an AQ, means it's strong. Insoluble means it's a weak electrolyte because it makes a few ions. So if it's insoluble, it's weak. And if it's covalent, it's a non. All right, good luck. Pause the video, give these a try. Okay, we're back. I'm going to show you the answers. If you need to pause now to write down the answers and check, go ahead and pause. Okay, we're back. So, I think what I'd like to do first is point out the covalent compounds. Let's look for non-metal compounds. Looks like number 5 is covalent, and it's not an acid or a base. So number 5 is covalent, it must be a non-electrolyte. Looks like number 8 is covalent, and it's not an acid or a base. So number 8 is covalent, it's a non-electrolyte. Now number 4 is covalent, but you should recognize H2CO3 is a certain type of chemical. H2CO3? Yeah, it's carbonic acid. So acids either break apart completely or break apart a little bit. Do you remember which one this one is? Yeah, it's weak. So number 4 is weak because it's a weak acid. Okay, you have to recognize your acids and your bases. All right, let's go back through looking at solubility rules for the rest of them. Number 1, BAS. That is strong because it is soluble. Rule number 9. Sulfide ion is insoluble except for calcium, strontium, and barium are soluble. So BAS is soluble, rule number 9. Number 2, AgCl. That is weak because it's insoluble. That's solubility rule number 4. Cl is soluble except with silver, mercury, and lead. So silver chloride is insoluble, which makes it weak because it means it dissolves a little bit. Number 3, KNO3. Rule number 1, potassium compounds are soluble. That makes it strong because it's soluble. We've already looked at number 4, weak acid. 5 is covalent. 6, sodium hydroxide. We should recognize that as a certain chemical. What is it? Hydroxide. It's a base. Sodium hydroxide is strong. Also, rule number 1, sodium is soluble. Soluble is strong. So that one's really easy to figure out. It's definitely strong. CaCO3. Okay, we need to look at our solubility rules for CaCO3, calcium carbonate. And we get to rule number 6. Carbonate is insoluble, means it dissolves a little bit, so it's weak. Weak because it's insoluble. We've already looked at number 8, covalent. Number 9, sodium phosphate. Sodium, again, rule number 1, soluble, soluble, strong. And then number 10, lead sulfate. Let's look for lead sulfate in our solubility rules. Okay, I found it in rule number 5. It says lead sulfate is insoluble. Remember, insoluble means it breaks apart a little bit. So insoluble means it's going to be weak. It's in the middle. It's a little bit soluble, mostly insoluble. So weak. All right. Expect a question like this on your next exam and on your final. Again, soluble, strong acids, strong bases, or strong electrolytes. Weak acids, weak bases, and insoluble or weak electrolytes. Only the covalents are non-electrolytes. So good luck with that. Alright, posted on the video, posted on the webpage should be these videos that you can watch for yourself. And we are at the end of Chapter 9. Thank you so much for watching. Good luck.